Alright, this is going to be notes on factoring. First, some examples. Factor out a -1. Factor out a -1 when that is not helpful, but still you can do it. Factor out a 6x cubed. This one we didn't factor anything out because there's not an n squared and there's not an n in all those three terms. There's not a 2 in all of those terms. 17's prime, so it's hard to factor things that are prime with integers. You can maybe factor them with rationals, but that's a story for another day. But if you follow this pattern of putting all of the a coefficient into one of the binomials, and then running through, you can see over here we tested out the factors of 21, so right over here. 21 times 1 or 7 times 3. You take them one at a time, so let's take the 21, multiply it by the 2, and then add the other one. So 21 times 2 is 42 plus 1 is 43. You want it to add up to the middle coefficient, the b term. It's coefficient, but that's 17, not 43. So that's not it. How about 1 times 2 plus 21? That's 23. That's not right. 7 times 2 is 14, plus 3 is 17. We got it. So the 7 has to be multiplied by the 2, and then we can add the 3 to get 17n. So that's why the 2n and the 7 are opposite each other here. 7's way over here. It needs to multiply by the 2n, which is 14n, and then the 3n will add 14n plus 3n is 17n. We got it. You can always multiply it out to check. So what are those steps? Step 1. Set up the binomial factors and put the a into one of them. Step 2. Check each of the possible factors of c by multiplying it by a and then adding the other factor until it adds up to b. Give you a second to write these down. Step 3, make sure you write the factor that needs to multiply by a in the other binomial. Make sure that the things that need to multiply will get multiplied before you combine like terms. Alright, let's run through. There's your binomial. There's the a term is 5, and it's prime. So we're going to park it into one of the binomials, in the first binomial over here. Okay, and the other one just gets an x. And already we have the 5x squared, right? 5x times x is 5x squared. Next target, we'll target the 8 over here. What are its factors? 8 and 1 or 4 and 2. So we take them one at a time, we multiply them by the 5. 8 times 5 is 40 plus 1 is 41, not 22. Next, 1 times 5 is 5 plus 8 is 13, not 22. Next. 4 times 5 is 20, plus 2 is 22. That's what we want. Okay, the 4 needs to be by the 5. Sorry, the 4 needs to be multiplied by the 5. So that's step 3. Make sure you write the factor that needs to be multiplied by the a in the other binomial. Here it is way over here on the other end. Ta-da! We did it. Now, why is this interesting to us? It's opened up the world of rational or fractional answers to equations like this. Before, when we had equations like this, they were only integer answers. But now, when we set this up, using the zero product property, the ZPP, either 5x plus 2 is 0 or x plus 4 is 0. So if we set up the 5x plus 2 equals 0 and solve for x, x is -2/5. That's our answer now. That's one of our roots. That's one of our solutions to a quadratic equation. We can now do any fraction with this by setting up the binomials with coefficients in them. Okay, one more example. This one with minus signs in it. Park the 3 in one of the binomials. Look at the -10. It's either 1 times 10 or 2 times 5. But now we have to make one of them negative, one at a time. So let's just take whichever one we multiply by 3, we'll make it the negative. Negative 1 times 3 is negative 1, plus 10 is 7. We want it to be negative 13. This might work. Negative 10 times 3 is negative 30, plus 1, negative 29. No. How about negative 2 times 3? That's negative 6, plus 5 is negative 1. Okay, it's got to be this last one then. We're going to make this 5 the negative. Negative 5 times 3 is negative 15, plus 2 is negative 13. Perfect. So now the negative 5 needs to be opposite the 3. So 3x times negative 5 is negative 15x, plus 2x, that's the negative 13x. And check the last rainbow, 2 times negative 5 is negative 10. Watcha. We did it. Do, 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 do. Pop.